Hello 7th graders, this is Mrs. Tremblay. Today's lesson is coming from section 10.5 in your book, and we've actually broken it up into two parts. So we're just going to look at part 1 today and talk a little bit about something called a linear function. You've actually been dealing with linear functions for a while now. I just don't think you knew it was called a linear function. The definition is it's a function whose graph is a line. So you've been graphing plenty of lines. Basically, a linear function, it's a relationship between x and y that when you plot them on a graph, they make a line. So, linear function. The y-intercept, again, I think you know what a y-intercept is. You just have to have the vocabulary word down. It's the point on the y-axis where the line touches it. So, the y-intercept is the y-coordinate of the point where the line crosses the y-axis. And the slope, of course, is still, if we're looking at a line, it's the ratio of rise over run. So if you have a linear function written in the form of y equals mx plus b, you've seen y equals kx. We're going to replace that k with an m at this point. So you've seen direct variation where y just equals some number times x. If you recall Buffy's example, y equals 10x. And remember that Bifford had y equals 10x plus 50. That's called slope-intercept form, because in that equation, you're given the slope and you're given the y-intercept. So slope-intercept form means it's written in the form of y equals mx plus b, where the slope is the coefficient of x, the number in front of the x, and the b is the number that's all by itself. So on a graph, there's your b, and the slope is still up and over how you get from one point to the next. Or you learn that you can actually go down and over as well. Or up and left. You can have negative slopes too. So basically our goal today is to be able to look at an equation and identify the slope and the y-intercept. Because in part 2 we're going to use that to graph. But we're just going to stick to identifying the slope and the y-intercept from the equations today because we need to work on some rearranging. You can only identify the slope and y-intercept when it's written in y equals mx plus b. Sometimes the y is not by itself, and yes, now is the time where you have to get the y by itself by rearranging these equations. So we need you to get really, really good at that. Okay, let's try a few. Zoom in a little bit here. Okay, so in this first equation, I'm hoping you can see that the y is already by itself. I am going to do keep, change, change because I can't help myself. I always have to. So I don't have to do any rearranging. All you have to do now is look at that equation and ask yourself, what's the coefficient of x and what number is by itself? So when I look at this, I see that -4 is right next to the x. That means it's its coefficient. That means that your slope, or m, is -4. Also, we just did a keep, change, change, and we see that this -2 doesn't have an x. It's all by itself. That means this is the b in the equation. B stands for by itself. Well, it stands for the y-intercept, but that's one way to remember it. So this graph would cross the y-axis at -2, and for its slope, -4 means that that's going to be a line going downward, and it's going to go down 4, and if it's written as -4, it really means -4 over 1. You remember from Unit 3, so you would go down 4, right 1, down 4, right 1 to get from point to point. All right, let's try the next one. This one looks a little bit different. It's not too much different, though. The y is already by itself. I'm going to keep, change, change. Remember, you keep the number, change the sign, change the number that follows the subtraction sign. Never change the number in front of the subtraction sign. All right, and looking at this one, I see that the number in front of the x isn't 12. It's a -12. And here we go. This 4 is all by itself. So that means it's b for by itself. So this graph would cross the y-axis at 4, also has a negative slope. You'd have to go down 12 and right 1 to get from one point to the next. Okay, C is kind of special. When you look at C, y is already isolated. Now in looking at this, I see, yep, the coefficient of x, my slope, is 7. But I don't see anything being added. Do you remember in direct variation when you had equations where nothing was being added? What point was on the graph? Hopefully you're thinking in your head, oh yeah, they all went through 0, 0. So when you look at this equation and we see that nothing's being added, isn't adding 0 the same as adding nothing? Yes. So if you see that there's no plus b, it doesn't mean that one doesn't exist. It means that this graph is going to cross the y-axis at 0, 0. So your b would be 0. So if you see nothing being added, it means 0. It means direct variation. Okay. Take a look at letter D. Okay, this one doesn't look too tricky, I hope. I'm going to keep change it. Y is by itself on this side of the equal sign. And honestly, that's fine. Remember when we solved equations, sometimes you would have 5 equals n, and sometimes you would have n equals 5. It doesn't make a difference that y is over here, as long as y is by itself, and y is by itself. So if it's in the form of y on one side and the mx plus b on the other side, you're good. The coefficient of x in this case, it's a -2 because we keep change, and the b by itself is 3. So this graph would start at 3, and the slope is negative. You would go down to right 1 to get from one point to the next. And that'll be our next lesson. We'll talk about how to graph those lines. Okay, letter E. I say okay a lot. I'm sorry. I can't help it. I watch these videos and I'm like, why do I keep saying it? Maybe someday I'll break that habit. We'll see. Do you see how y is not by itself in this one? I'm going to keep change. When y is not by itself, before you can identify the slope in the y-intercept, you have to get it by itself. Because right now you might think, oh, the slope is 3/2 and the y-intercept is -5, but it's really not. So draw your line, and we're going to take the steps we need to get this y by itself. In a regular one-step equation like this, if you saw y plus -5 equals something, wouldn't you just add the opposite of 5 to get rid of it? Good news. You do the same thing here. So I'm going to add 5, add 5. This -5 plus 5 are 0. And y plus 0 is y. Y is finally alone. And over here I have 3/2 x plus 5. Remember, those are not like terms. This 5 does not have an x. So when you see that there are unlike terms to be added, you just need to rewrite them. So I have 3/2 x plus 5. Now that it's written in the form of y equals some number times x plus 5, we're just going to identify those. So m, the number in front of the x, yeah, it's a fraction. It's great when it's a fraction because the slope is supposed to be a ratio of rise over run. So I'm just going to go ahead and write 3/2. I'm not going to change it to 1.5. I'm going to leave it just like that. The number by itself is 5. Now, in the beginning, we thought, oh, it must be -5. But when we rearrange this, it's actually a +5. So the b is 5. So this graph would go through the point 0.05, and you would go up 3, right 2, to get from one point to the next. All right, last one in this row. Again, hoping you're noticing, uh-oh, y is not by itself. I need to get the y by itself. 3 is being added to it. So I'm going to add a -3 to each side. Those cancel out. Y is left over here. And again, -x plus -3, those are not like terms. I can't combine them, so I'm just going to rewrite that expression. Now this one's a little bit tougher to identify the slope, but once I show you how, I know you're going to be just fine with it. Let's start with the b though, because the b in this one, that's not too bad. There's the number by itself. It's a -3. So I'm going to write b equals -3. Now finding the slope. This is where I get a lot of people that make the common error of saying, oh, your slope is -x. If your slope is the coefficient of x, you can't write x for your slope. The slope needs to be a number, not the letter. So what is the number in front of the x? Well, I see that there's a little negative sign, right? I don't see a number in front of the x. Do you remember what we do when there's not a number in front of the letter? Hopefully you're saying, yes, put a 1 there, Mrs. Tremblay, move on, I know. Remember, when there's not a number in front of the x, it really means that there is a 1 there because I have 1x, And in this case, because it's negative, that means I have negative 1x. So your slope in this one is a negative 1. That means you would plot negative 3. That would be your y-intercept. And a slope of negative 1 means you would go down 1, right 1. All right, last row, I saved the toughies for last. I have 4y minus 4 equals negative 3x. Now in looking at this, I'll keep change first. Y is definitely not by itself. I want you just to look at this side and pretend it's a two-step equation. If this was just a two-step equation right here, wouldn't you get rid of that negative 4 first? Yeah, your job is to isolate the variable term first by adding the opposite of whatever's being added to it. So let's do that. Let's get rid of this negative 4 on the same side the y is on. Those negative 4's will cancel out. They're gone. What you're left with now is 4y equals, and those aren't like terms, you can't combine them, so just rewrite them. You're left with 4y equals negative 3x plus 4. Y is still not by itself. How do you get rid of a number next to a letter? How do you undo multiplication? You use division. So I'm going to divide this side by 4 like you're used to, and you're like, yes, y is by itself. But how on earth do I divide all of this by 4? What I would recommend is that you divide everything by 4, right? Because if you divide this side by 4, you need to divide every term over here by 4. So again, terms are separated by addition signs. Negative 3x is a term and 4 is a term. I'm going to divide both of those terms by 4. Okay, so we see that I have a negative 3x over 4. This really means negative 3/4 x. And we had talked about this when we had just started direct variation, and we were trying to see, is it in y equals kx form? Which now we're going to call it y equals mx form. I don't know why the letters change, I'm sorry. So I want slope to be a fraction. I want to have the rise and the run. And 3/4 is already in simplest form. So when you see this happen, just rewrite it. Negative 3/4 times x. And 4 divided by 4 is 1. A little bit tougher, but not impossible. Now in looking at this equation, the coefficient of x is negative 3/4. That means my slope is negative 3/4. And my b is 1. All right. Next one, I know we need a couple more of those, and I think we'll be okay. And we'll be doing more practice in class. So if it's not clicking just yet, don't panic, we'll get there. Okay, this is my variable term. It's not by itself. I've got some work to do to get y alone. I want to get rid of the number being added. A positive x is being added. To get rid of a positive x, I'm going to add a negative x. Those are gone. You're left with negative 5y, and on this side, those cannot combine. Don't you dare write 25x. Write 25 plus negative x. Those are two separate terms that are not like terms, so we can't combine them. Okay, y is still not alone, so I'm going to divide by the number it's being multiplied by so I can get it by itself. Remember, you have to divide every single term by a negative 5. So that's gone. We finally have our little y by itself. Let me write it down. 25 divided by negative 5, not too bad, that's a negative 5, plus. Okay, I have a negative x over a negative 5. First thing I want you to remember is this does mean negative 1x over negative 5. What's a negative divided by a negative? Because that's what this is saying. It's saying a negative 1x divided by a negative 5. A negative divided by a negative is a positive, right? So what I'm left with here is 1/5. You don't need to write that as a decimal. I want slope to be a ratio of rise over run. So I'm left with 1/5 times x. And again, we'll be doing more of these in class for sure. So the coefficient of x now, we're ready because y is alone, is 1/5. That means my slope is 1/5. And the number by itself is negative 5, so my b is negative 5. So that graph would cross negative 5 on the y-axis. And to get from one point to the next, you would go up 1, right 5. All right, last one of these. Yay! Okay, keep change it. We weren't kidding when we said you'll be doing that for the rest of your life, pretty much. So here's 2y. My first step is to get the 2y by itself. I do that by getting rid of this negative 6 that's being added. How do you get rid of a negative 6 that's being added? You add 6. Those are gone. 2y equals, this is not 9x. It's not. 6 doesn't have any x's. So I'm going to rewrite this as 3x plus 6. Okay, y is still not by itself. I need this 2 to go away. It's being multiplied, so I'm going to divide. Whatever I divide this side by, I have to divide every term by it over here. Those cancel out. I am left with y by itself, and I have 3 halves x. Now I know that 3 halves is equivalent to 1.5, and it's also equivalent to 1.5, and I also know there's not a number other than 1 that goes into 3 and 2. So because this is a slope, I want you to leave it as a ratio. So we're going to leave it as 3 halves x plus 6 divided by 2 is 3. If this was like 4 over 2, I could go ahead and write 2x. But because it's an improper fraction that no other number other than 1 will go into, I can leave it. I'm going to leave it because when I go to graph this, I want to know that I go up 3 and right 2. So that's what the slope of 3 halves means. It means up 3, right 2. If you wrote 1.5, it makes it really tricky to know the rise over the run. See what I'm saying? Alright, the 3 is by itself, so by itself, b is 3. Alright, we'll do some more practice in class tomorrow. See you then.